So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic heat energy. So guys, this video will be about gas laws, heat capacity and heat transfers. So in short, to stay till the end of this video, let's go ahead and start with the first question here. It says, which of the following units is the SI unit of heat capacity? So we have A, joule per kilogram per Kelvin, B, joule per gram per Kelvin, C, joule per Kelvin, and D, joule per kilogram. So guys, the correct answer to this question is option C here. That's joule per Kelvin. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 2 here. It says, the vacuum in a thermal flask reduces heat loss resulting from A, radiation only, B, conduction only, C, radiation and convection only, D, conduction and convection only. So guys, the answer to this question is option D here, conduction and convection only. So guys, the vacuum in a thermal flask reduces heat loss by conduction and convection only, because these are the two processes of heat loss that actually require a material medium for their propagation. So you notice that radiation can occur even when there is no gas, liquid or solid medium. But guys, conduction and convection require either a solid, liquid or gas medium. So in a vacuum, you find out that this is either reduced or almost gone. So that's why the vacuum in the thermal flask reduces heat loss resulting from conduction and convection. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 3 here, guys. The question says, the heat capacity of a substance is the energy A, absorbed by the substance at constant temperature, B, required to raise the temperature of a unit mass of the substance by 1 degree, C, lost by a unit mass of the substance, D, required to raise the temperature of the substance by 1 degree. So guys, the answer to this question here is option D. The heat capacity of a substance is the energy required to raise the temperature of the substance by 1 degree. And that's it for this question. So let's go ahead and consider the next question, guys. So guys, we have here question number 4. It says, a piece of metal of mass 50 grams is cooled from 80 degrees Celsius to 20 degrees Celsius. Calculate the amount of heat lost. So we have the specific heat capacity of the material to be 450 joule per kilogram per Kelvin. So guys, all we just have to do here is to first of all get the formula for this question. And guys, the formula we're going to use here is H is equal to MC delta theta. So where M here is the mass of the metal, then C is the specific heat capacity, and then delta theta is the change in temperature. So guys, if we have to plug in the values we have here for this question, we're going to have 50 grams is actually 0.05 kilograms times 450, then times, so the change in temperature here will result as 60. That's 80 minus 20, that's 60. And guys, when you multiply this out, you'll have 1.35 times 10 to the power of 3 joules. And that is for this question, guys. So let's go ahead and consider the next question, guys. So that's question number 5 here. It says, the pressure P, volume V, and absolute temperature T of a given mass of an ideal gas change simultaneously. which of the following equation is correct about the gas? We have A, P over T is equal to constant. B, 1 over T is equal to constant over PV. C, P over V is equal to constant over T. And then D, PV is equal to constant over T. So guys, for this, let's recall that the product of the pressure and the quotient of volume and temperature is constant for an ideal gas. So we have that P multiplied by V over T is equal to constant. So if we make this that way, then we can simply say that PV over T is equal to constant, and perhaps PV is equal to T times constant. So if we rearrange this equation, we are going to have that 1 over T is equal to constant over PV, and that's it for this question. Option B is the answer to this question. So let's go ahead and consider the next question, guys. So question number 6 here says, the heat capacity of a calorimeter is the amount of energy required to A, change the temperature of the calorimeter by 1 K, B, change 1 kg mass of the calorimeter to liquid at the same temperature, C, melt the calorimeter into liquid at a constant temperature, D, change the temperature of 1 kg of the calorimeter by 1 K. Alright guys, so the answer to this question here is option A. The heat capacity of a calorimeter is the amount of energy required to change the temperature of the calorimeter by 1 Kelvin. And that's it for this question. So let's go ahead and consider the next question, guys. So that's question number 7 here. It says, in a thermos flask, heat loss by radiation is minimized by the cork support, plastic stopper, vacuum within the double walls, silvered surfaces. So guys, the answer to this question is option D here, the silvered surfaces. So in a thermos flask, the heat loss by radiation is usually minimized by having silver surfaces that can cause reflection. So that's it for this question. So option D is the answer to this question. So let's go ahead and consider the next question. And that's question number 8 here. It says, on the basis of the kinetic theory, an increase in the temperature of a fixed volume of an ideal gas causes A, a decrease in the pressure exerted by the gas, B, an increase in the average speed of the gas molecules, C, an increase in the number of the gas molecules, D, a decrease in the density of the gas. So guys, the answer to this question here is option B. Based on the kinetic theory, an increase in the temperature of a fixed volume of an ideal gas will cause an increase in the average speed of the gas molecules, and that's option B here. So that's it for this question, guys. Let's go ahead and consider the next question. So that's question number 9 here. It says, the inside of a thermos flask is usually coated with silver to reduce heat loss by A, absorption, B, conduction, C, radiation, D, convection. So guys, obviously the answer to this question is option C, and that's radiation. So that's it for this question. Let's go ahead and consider the next and last question, guys. So that's question number 10 here. It says, A, at temperature 5 to 7 degrees Celsius and pressure 30 atmospheres, is admitted into the cylinder of an engine. Calculate the pressure of the gas when it has expanded to 5 times its volume and cooled to 127 degrees Celsius as it leaves the engine. So guys, In order for us to solve this, let's go ahead and use the formula. P1 V1 over T1 is equal to P2 V2 over T2. So they said calculate the pressure of the gas when it has expanded to 5 times. So that's the final pressure, P2. So P2 here is going to be P1 V1 T2 over T1 V2. So guys, if we state out all the parameters here, let's note that P1 is 30 atmosphere, and then T1 is 527 degrees Celsius. If we convert this to Kelvin, we're just going to add 273, and that will give us 800 Kelvin. So for T2, that's 127 degrees Celsius. In order to convert to Kelvin, we are going to still add 273 Kelvin, and that will give us 400 Kelvin. So V1 is not given here, so let's say V1 is V, that's volume, and then V2 is 5 times V1, so that's 5V here. So let's go ahead and substitute all these in the equation. So P2 is going to be the P1, that's 30, times the V1, which is just V, then times the T2, which is 400. So this will be over the T1, which is 800, times the V2, which is 5V. So guys, when we just go ahead and calculate this all together, we'll have 3.0 atmosphere, and that's option B here. So guys, option B is the answer to this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll be sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, guys, and see you on the next one.